Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco DevNet, and today I want to talk to you about REST APIs Part 2, making REST API calls with Postman. This is a part of our Network Programmability Basics video course, and it's within the Programming Fundamentals module of content. This is our second lesson on REST APIs. If you haven't seen or checked out REST APIs Part 1, you might want to go back and take a look at that because we're going to pick up from where that one left off. Now, if you want to follow along as I go through, please do. I encourage it. You can grab all the code and details on our example up on GitHub, on github.com/Cisco DevNet, netprog_basics. And you can download and get access to all the code samples and information for these lessons. Each lab includes a README, which details how to get access to all of the prerequisite tools, features, utilities, how to get your laptop or your workstation set up to run them. And if the lab's examples require some sort of access to infrastructure, the DevNet sandboxes are ready to go. And included in each lab README are details on how to reserve and which sandbox to go ahead and reserve to execute these labs. All right, let's jump in. So what are we going to cover in this lesson? We're going to talk about why Postman and how you get it. Why would you want to leverage it, and how do you get started using Postman? We'll look at using Postman to send REST API requests, and then how do we use some of the powerful features of Postman to make our lives easier. We'll look at collections and environments, and then finally we'll end with how we can take those REST APIs that we've built inside of Postman and convert them directly to code so that we can jumpstart our actual scripting capabilities that are out there. So why Postman, and how do we get it that's out there? Now, Postman is a powerful but very simple REST API client that lets you quickly test those APIs in a GUI. Eventually, we'll want to take those REST APIs and put them into code, but if you just want to make sure you understand how a REST API works, how to construct it, how to deal with the authentication and the headers, nothing's better. Well, in my opinion, nothing's better than using Postman to get started. What's also nice is as you test out those APIs, you can save them into collections to make them easily to be able to be reused. Manage environments. Maybe you've got an API that goes against a production system, a development, a QA. Well, we can save that API once and then use environments within Postman to switch back and forth, and we'll take a look at how that works. And as mentioned, we can take those APIs and generate code. Now, how do you get started with it? What's nice about Postman is we got a couple of options. If you use Chrome as your web browser, or if you have it but you don't use it all the time, you can just go in and you can add the Postman plugin as an application to the Chrome web browser. If you don't want to do that, if you think you're going to use Postman a lot, you can actually download it as a standalone application as well. So www.getpostman.com gives you all of the information on how to install and get started that's out there. Now, once we have it installed, let's take a look at how we send an API request. How do we send a REST request using Postman? Now, the graphical interface for Postman looks like this, and we navigate ourselves around it through the whole process of sending our request and retrieving our response. Now, REST APIs start with a URI that's out there. And what we can see here is up at the top, we can see our URI, and we enter that in. Now, to the left of the URI, we have our method. REST APIs will have different methods that we might interact with. We've got GET request to retrieve data, POST, PUT, DELETE, depending on the action that we're after at the time. Now, with our URI and our method set, then we move into the actual details about the request, the authorization information, headers, and data that we may have to send if it's a POST or a PUT request that's out there. Now, underneath that table that's there, we can easily input our headers using auto-completion. Don't recall the exact format of what the content type header is, whether there's a dash and where the case sensitivity is. Postman will auto-complete that for you. And then for headers like accept or content type, with all of the list of common application types that you might be out there, whether it's JSON or XML or the other ones that are there, you can jump back to those as well. Now, once you've got your REST request or your request fully formulated, then click the Send Request button up at the top, and that will send your request out to the endpoint that you're targeting. Now, when that response comes back, the first thing you want to check is the status code available in the corner here. If you see that 200 OK and it was a GET request, awesome. If it was a POST request and you got a 201, also awesome. If you get a 400 or a 500 series, not quite so awesome. Something's not quite right with your API call. Once the API comes back, you can dive into the elements of the response using these tabs. You can see the body and the headers and all of the other information that's available and view the actual detail. Now, if that data came back in an understood format like JSON and Postman could format it, it'll go ahead and mock it up in a pretty format for you so it's easy to use. But you can always get to the raw details under the hood using the Postman interface as well. So this is a basic GET request. What about a post? And there's our response body that's in there. We can see the response detail that came through. Now this was our GET request. What about a post request? What if we want to send information using post, put, or one of the other ones? Well, the first bit is to change that request method. We can see in our screen here, we're now sending a post request as we go through. But what you'll notice inside of the post request is we have to specify some headers. So underneath the headers area, we're going to set our content type to application JSON to identify what type of data we're sending up, and we can see that outline there in the red box. Now in this case, the body of content needs to be identifying the username and password. It's just the type of request that this is going to go through. This is targeting Cisco's APIC EM controller. We'll talk more about that in a later lesson. But here we can see inside of the output, we're providing the body data with the username and the password that's there. Then we can send it and verify our status in the lower right corner, and we got our 200 back. Now, one of the features of Postman that I like are API collections. You're going to be finding yourself gathering up APIs for all the different services and infrastructure that you're going to take advantage of. And you don't want to have to reformat those APIs every time. Postman lets you go ahead and save those as collections so that you can come back and forth to them as you need to. You'll find collections on the left-hand side of the Postman interface, and they show up looking like a folder structure. Here outlined in red, we can see the APIC EM collection that I have stored inside of Postman, with all of the different API calls. Some of them GET, some of them POST that goes through. Now once you've built your API call the way you want it, just click that Save button, and it'll open up an interface where you can give that request a name and a description, and then you can store them in different collection folders should you want to that are out there. Now environments are the next big piece that really make Postman super powerful as you go through. Now before we dive into exactly what an environment is, let's look at the problem that environments solve. And so variables are what we want to go after. So what we've seen so far is we've been hard coding details into our API requests within Postman. So in the URL or the URI, we can see that we've got apicem.cisco.com hard coded into the API request. We've hard coded the username and password. What happens if those credentials change? What happens if I want to connect to a different APIC EM controller? Now I could copy this over to a new window and a new interface. I could save those details, store them in collections as we've seen. But that's a little bit too much reuse, right? There's got to be a better way is what I usually say. And there certainly is. And this is where environments come through. We want to take those variables and we want to divide them up. We want to change our API requests. So rather than putting the actual fully qualified domain name or IP address inside of the URI, we put a variable reference in using double curly braces and then APIC. And then inside the body where we've got our username and password, I use double curly braces username, double curly braces password. Now, this API request, I can save it in a collection and I can just update those variables that go through. And it's that variable storage, that's what an environment in Postman is it lets you store different environments or instances of settings of these data that are out there. And so up inside of the Postman window, you can create any number of environments you want by using the gear that's boxed in red right there. By clicking on that gear button, it'll open up, and what we can see is our Manage Environment screen, where we can view, edit, and then create as many environments as that we want. Once we've created the environments that are out there, we can change between them using the drop-down list that's highlighted there in yellow on the screen. Now inside of each environment, what we end up with is a list of variables that we want to set. So in this example, we can see we've got the APIC variable, username, password, and port that are stored. Now as we saw in the REST request that we saw, we've taken that APIC variable and we're inserting it into the URI using the double curly braces APIC. And then the username and password get pulled down in there. When you create different variables inside of environments, you can reference them nearly anywhere inside of Postman using the double curly braces and then the name of the variable in the syntax that's out there. Now what about dynamic variables, right? What about if you take information from one request and you need to use that in a follow-up request? So in this example, the way APIC EM works is we make a login request and that gives us back our service ticket that we would use to authenticate and authorize follow-up API requests that are there. Now after we make the login request, the body of details that come back will have the service ticket. That's what APIC EM calls the tokens for authentication. And I need to take that and I need to put it inside of a header called XAuth token to authorize and authenticate our API request. Now manually copying and pasting that from the body of one request into another request header information is slow as well as quite error prone. And then if you were to set those with environment variables, but manually update the environment every time you logged in, well, that's also slow and a bit awkward to go through. So once again, there must be a better way, is what I always say. And that's where some of the dynamic nature of Postman comes in. So Postman gives us the ability to use tests as follow-up actions after a request. Now, if you have something you need to do before you send a request, you can use what are called pre-request scripts. But in this case, we're going to take advantage of tests to write a test that lets us dynamically create a new environment variable in the system. Now, our tests are written in JavaScript, but if you're not familiar with JavaScript, never fear. The most common use case for this that you're probably going to run into is exactly this one, where you want to take output from one request and store it as an environment variable. So you can just simply use this code that's examples here in your environment. So the way that we read this code as we go through is we're going to go ahead and reference the response body, and we can see that in the line 1 of the code. Var JSON data equals json.parse response body. So you take that, and all it does is it looks at the response body from the previous API, or that API request. Assuming it's JSON, it then processes it into a JSON object, a JavaScript object that you can reference. In our second line, what we're doing is we're pulling out the JSON data dot response. That's the first level object inside of the JSON body. Dot service ticket. That's the second level embedded. And it's going to grab the value from that key and store that as a new environment variable, in this case token, as we can see in line 2 inside of the interface. We can verify that that was successful by using the little eyeball in the corner to look at all of the current environment variables and see that indeed that service ticket has now been stored as an environment variable. With that successfully stored inside of our environment, we can then use it. Now let's take a look at all of the goodness that Postman offers us as API users inside of a live demo and take a look at what we've just seen. All right, now that we've taken a look at how Postman works inside of the slides with that part of the review, let's do a live demo. So the first thing to notice here is I want to start out with that collections view because we want to save our API calls. So underneath collections and inside of APIC-EM folder, I can see the different requests that are there that I've set up. So if we look at this APIC-EM login request that we've been talking through in some of the content, I can see how it pops up. And so here I've got my URI, right, with the variable stored that we talked about using the environments that are in there. This is a post request as it goes through. So if I click on here, we can see all of the different API methods or the REST methods available. Now the first 5 are the ones we talked about: get, put, post, patch, and delete. But as you'll notice, HTTP actually has many more methods and verbs. But the ones that we want to pay the most attention to are those ones we've talked through. Now to make our request, we need to make sure that we've got all of the details completed. So for this request, we've got our headers, content type, application, JSON. And as I mentioned, Postman is really handy. So if I had other headers to set, maybe I needed to set the accept header, just type the first few letters for that, and it'll drop down and give me some suggestions. So my accept header. And then I also want to accept application JSON. So start typing, and it'll filter down and show me some possible suggestions, in this case, application JSON. Now, as a post request, I need to send some body data up. So if I look at the body, it'll show me here where I've got my username and password formatted, and I'm including my dynamic variables here using from the environment of username and password. Now I can see those variables by using the eye here in the corner, where I can see that my current settings for the user or the APIC username, password, token, all of these information are stored and available. Now once I've got my API request created correctly inside of the GUI, I can simply hit the send button, and this will send my request off to the destination service. Drag this up so we can see more of it. All right, never mind. I'll just scroll down. So if I scroll down here, we can see we've got our 200 status OK back, so we know that our API request went successfully. And we can take a look at the body and the details. So here in the body, I can see that my response came back with my service ticket. And if I was interested in the headers that came back, I can simply click on headers, and it will flip over and show me the different response headers that came through. Indeed, my content type is application JSON as requested. Now, one of the other things we talked about with Postman was the ability to use dynamic variables with the environment. So inside of our request, I've got a test configured. And inside this test is the one that we looked at in the slides, where I'm going ahead and parsing the response body. Now that response body, again, is just what came back when we sent the request. We can see that down at the bottom. And then what we want to do in this case is set an environment variable called token equal to the response.service ticket. So if we look at the response body, we're going from response here dot service ticket for the second one. And then that value here of the ST and then the full contents of the ticket will get stored as a new environment variable called token. And indeed, if I click on the I, we will see that that is stored there under token, ST901, and then the letters. Postman gives us that ability to go through and do that. Now that I've got my token in place, right, I want to make another API request. In this case, maybe I want to get a list of the network devices that APIC-EM supports. By selecting that for my collection, I can go ahead and immediately hit send, because this API request is using all of the environment variables that are there, including the authentication information from the token stored here that was dynamically populated. So as we can see, Postman makes it really easy to get started, store, save, and leverage these different API calls that are out there and build ourselves a full library for it. Now that we've seen how we can use Postman to create the APIs and manipulate them, save them in collections, work with environments, let's look at what happens when we want to move from Postman into actual code that's out there. Now, Postman is great for testing and validating and proving out that the APIs work as expected, but it's about atomic actions. You can script them together, use pre and post and test scripts, but at the end of the day, it's really about just making one API call and then another one. Business logic, trying to actually accomplish something of value, often requires stringing different APIs together, and we need code to make that accomplished. The good news is Postman can help us by auto-generating code that represents the API requests that we've built and stored in our collections. We can do that by clicking on the code button here in our API inside of the Postman window, which then opens up all of the example options that we have. Now, Postman supports a huge library of different languages that are out there. If you want to work in Python, it'll support requests as well as URL-lib, a couple of things we'll look at later. But if you're not using Python, maybe you're using Go or you're using JavaScript, Postman can create API code examples for those as well. And once you've selected the language that you want to work with, you'll be presented with the actual code that was your API request. All of the headers, payload data, URI information are included inside of the code. Now, one thing to note here is the environment variables are put directly in. So even though you may be using a variable to represent your username and password, those get hard-coded into the code. That means that this is a great starting point, but you should expect to have to update and customize the code for exactly what you're after. You can test, this code should run exactly as your API request did, but to actually accomplish what you're after, you're probably going to have to do some code changes on top of what Postman auto-generates for you. Now, in summary, let's take a look at what we've seen. We've seen how Postman offers us a great use case and a great tool for API developers, taking advantage of learning how different APIs work. We looked at sending basic requests, both GET requests as well as POST requests, to use the different methods available to REST APIs. We saw how we can save all of our APIs into collections and then leverage environments to make them super modular and powerful. And then lastly, how we can take those APIs from Postman and turn them into code across many different languages to jumpstart ourselves into the actual programmability area. Now, call to action, right? This is just a part of our Network Programmability Basics course. I highly encourage everybody to complete the full Programmability Basics course to arm yourself with all the tools necessary. And if you didn't run the examples along with the video or along with my demo, that's fine. Take some time now, run those examples, take a look for bonus examples included in the repo to look at and reinforce some of these tools. And be sure to join DevNet. Come sign in, take advantage of the learning labs, the development sandboxes, and more that we have to offer for developers trying to get started. Or if you've been developing for a while and you're looking for good examples and resources, DevNet's got you there too. Now, if you have further questions, come find me. You can find me on Cisco Spark or email at hapresto@cisco.com. I'm active on Twitter at hfpreston. And up on GitHub, you'll find me posting code. Occasionally, it's even worth looking at github.com/hpreston. Also follow Cisco DevNet across all the social medias, including Facebook, Twitter, and of course up on GitHub for resources across all of the different architectures and capabilities that are out there. Thanks so much for joining me on this video course. Please stay tuned. Next up after this, we start diving into Python and how we can use Python for programming across the network and other areas as well. Thanks.